Hi everyone, welcome to MPEV. We're building a recycled laptop battery for a solar panel lighting system, and this has been running for about 16 years, and this is its upgrade. The first thing we got into was some playing around with fuses just to see what sort of current they blow at, and that was a bit fun, just to make sure that we're nice and safe. And so we got into that in various ways using a desktop power supply and then just plugging batteries in short circuit just to see where they blow. So here you can have a bit of a look at what's going on here. I think that one's about to go. So yeah, I hope you enjoy the video. It gets into a bit of testing of the battery pack with an active load, and then a little bit of a walk through the property, showing you where this thing's plugged in, and a little bit of operation. So enjoy. Thanks.
Alright, this is the first test of our solar battery system. You can see our voltage is currently at 16.2. We've got some flashing lights there, basically showing everything's in balance. This device over here thinks there's 16.1 volts, so we're now going to turn on. So this is an active load. We're now going to turn this active load on and tell it to draw some current. So how about 8 amps? So that's going to get hot, one would think. Those little wires might get warm too. Not too bad. So we see our voltage dropping here, 15.6. We also get total watts, how many amp hours, time, temperature of this unit. Oh well, we'll see how that pans out. Okay, so that's been running for about 40 minutes, and should be able to see what's going on there. Drawing 9.35 amps, voltage is down to 14.6, 90 watt hours, 6 amp hours, and currently 137 watts of dissipation by this little device here. So we'll just do our cell checker. So the difference between all the cells is only 0.073 volts, which is fantastic, which means our balancer doesn't need to kick in, which it hasn't. So we'll probably call that a successful test. Time to install. Okay, we've installed the battery finally. This is where we built it all, and we'll go for a walk and have a look at it all installed. There's the cat. Look at that. Look at that cat going. There's a dog. Chewy. Hello, Chewy. Hello, Chewy. So we've got the old lead acid battery there, the old controller, seen better days, pretty rusty sort of thing going on there. We've got a box on the wall, temporary cable installation at the moment. So what we can see here is our little MT50 giving us some numbers and stuff. Telling us that we've got 0.9 amps
coming out of our solar panel on 1 amp now, 17 volts out, 16.4 volts on the battery. All of that's going in. Just turn the light back on there, get rid of the watery bits. 1.2 amps going into the battery, and no load at the moment. So we'll have a look inside. Noisy. So there's our battery that we've been building, which has some pretty little flashing lights on it. That's an extra load balancer on top of the BMS, which is sitting in the corner there. And with our controller here, which has been set up to be suitable for this battery, which is, we're going to run at about 16.4 volts full charge. So that'll be 4 times 4.1 volts. And this system can do about 15 amps. That controller can handle 10. The battery, etc., can handle a lot more than that, of course. We've got some fuses in the line here, as you can see, just in case. And yeah, she's all operational. Alright, so we've got a load on it now, which is about as much as this thing's ever going to get loaded, which is 50 watts, which isn't a lot of power. And this is a 16-year-old experiment. So we've been through 37 watt panel, motorbike batteries, then the big upgrade to 80 watts, and lead acid car batteries, maybe a deep cycle lead acid battery, and now lithium using repurposed old laptop batteries. So at 50 watts we can get about 9 hours continuous without any sun, which most of the time this system never uses 50 watts. Its typical load's about 12. Alright, so this is a more typical load for this system, 12 watts. Everyone's probably saying, wow, that's not much. Yeah, that was the plan from day one. How low can you go and still be useful? So this is currently powering the office. So 12 lots of LED globes with around about a 460 watt hour battery's going to give us about 30 hours of light without any sun at all. So 30 hours of light's typically used about maybe 5 or 6 hours a day. So we should be able to get around about a week out of that, assuming there's no sun at all. So southern Victoria in Australia in winter, yeah, we're going to get some sun, but you know, maybe a few days in a row, 3, where it'll be very minimal. So it should be fine. We'll see over the next week or two.